In this part of the video, we're going to learn how to name and draw alkanes and cycloalkanes. Now recall that hydrocarbons are compounds consisting of carbon and hydrogen atoms, and we have two classifications, acyclic and cyclic hydrocarbons. When we say acyclic, these are linear or branched chains, meaning they are open, right? When we say cyclic, these are compounds or organic compounds that have rings or closed structures. So for acyclic and cyclic, you can have saturated and unsaturated. For saturated compounds, they are bonded by single bonds, and we call them alkenes or cycloalkanes. Unsaturated, you can have alkene or alkyne. When you have alkene, you have double bonds, so we call them alkenes or cycloalkenes. If you have triple bonds, you call them alkynes, or we call them cycloalkynes. Okay, let's first start with alkanes. Again, alkanes are single-bonded organic compounds that can either be linear or branch, and they follow the general formula CnH2n plus 2, meaning if you have 4 carbon atoms, the hydrogen atom is equal to 10. So how do we draw alkanes? First is to determine the number of carbon atoms in the alkane. You will see this in the molecular formula. Draw a chain of single bonds between carbon atoms. Finally, attach the correct number of hydrogen atoms. Let's have an example. For example, you are given C5H12 and asked to draw a linear alkane. So again, you have 5 carbon atoms, so you draw 5 carbon. 1, 2, 3, 4, 5. And then you attach single bonds. Now remember, carbon is tetravalent, so it can form 4 bonds, right? So this carbon is already bonded to this carbon, so you've used this one, meaning you can now only form bonds with hydrogen. So this carbon would have 3 hydrogen atoms. This carbon is bonded to this carbon and this carbon, so only 2 hydrogen atoms can bond, so we write CH2. This carbon is the same, bonded to this carbon and this carbon, so only 2 hydrogen atoms can bond. This carbon is the same, and this carbon is only bonded to this carbon, so again you have 3 more bonds left, so this can have CH3. Okay, if we're going to count the number of hydrogen atoms, it's equal to 12. The number of carbon atoms equal to 5. Now, we can also use the line angle formula, right? So again, a line angle formula do not show the carbon atoms and the hydrogen atoms. So the vertices and the points, they are all considered carbon. So we have 2, 3, 4, 5. So this is your carbon 1, 2, 3, 4, 5. Now you are asked to draw C7H16. Here you will draw a branch organic compound. Okay, so let's start with drawing the number of carbon atoms. 1, 2, 3, 4, 5, 6, and here. So we draw single bonds. Okay, and then we attach the correct number of hydrogen atoms. So again, this one has 1 bond, so you can only have 3 hydrogen bonds. This will have CH3. This one is CH2. This is CH2. This is CH2, CH3, and CH2, and CH3. Now, so this carbon has already 1, 2, 3 carbon-carbon bonds. So how many hydrogen atoms can bond? Only 1. Because again, carbon is tetravalent or can only form 4 bonds. So that would be, so if we're going to count the number of bonds, 1, 2, 3, 4. So this is a branch alkane following the molecular formula C7H16. Now, in naming cycloalkanes, it's almost the same. Again, cycloalkanes are single-bonded organic compounds that has a ring. Unlike alkanes, they follow the formula CnH2n. So meaning if you have 3 carbon atoms, the number of hydrogen is 6. Okay? Now remember, cycloalkanes have more priority than alkanes. So if you have a cycloalkane and alkane in a single compound, the name would be based on the cycloalkane. Okay, so here are the steps in drawing cycloalkanes. First is to determine the number of carbon atoms in the alkane. Now, the key here is to know your polygons. So once you have determined the number of carbon atoms, draw a polygon representing the carbon ring. So if you have 4 carbon atoms, you will draw a square. Okay. Then attach the correct number of hydrogen atoms. Let's have an example. So here you have C5H10. So again, N2N. Right? Determine the number of carbon atoms. You have 5. Draw a polygon representing the carbon ring. 5 is a pentagon, so you draw a pentagon. Attach the correct number of hydrogen atoms. Now, usually or most of the time, we don't show the number of hydrogen atoms in a cycloalkane. But just to show you, these are the hydrogen atoms. Again, this carbon is bonded to this carbon. This carbon is bonded to this carbon, so you have 2 bonds. So you can only have 2 hydrogen bonds. So CH, CH. Or we can write CH2. Okay. Next, here you have 7 carbon atoms and 14 hydrogen atoms. The polygon is a heptagon, right? So we draw a heptagon. So you have 1, 2, 3, 4, 5, 6, 7. So this is the C7H14. That is a cycloalkane. Now that we know how to draw them, let's now name them. The first step is to identify the longest chain. Longest chain is basically the longest pattern or carbon-carbon pattern in the compound. So since we're talking about alkanes, the name would end in "ane." And the prefix that you're going to use depends on the number of carbon atoms. So if you have 1 carbon atom, that's meth. 2, eth. 3, prop. 4, bute. 5, pent. Okay? So that's it. That's the first step. Second step is to identify the substituent or substituents. When we say substituents, these are the carbons that are not part of your parent chain or the longest chain. So the prefix would be the same, meth, eth, prof, bute, but instead of ending in "ane", they will end with "il". So if you have 1 carbon substituent, that would be methyl. If you have 2 carbon substituent, ethyl. If you have 8, that's octyl. Okay? Then, number the carbon atoms starting from the end closest to the first substituent. Or it would depend on the situation. But what you have to remember is that the substituent must have the lowest number possible. Okay? Consider this example. So when we go from left to right, this substituent will have a number 3. This one would have number 5. But if we go from right to left, this substituent will be number 4. This substituent would be number 6. Okay, so 3 is lower than 4, so we go from left to right. Lastly, assemble the name. The formula of the name would be the position number of the substituent, followed by dash, then add the name of the substituent, dash, and then the alkane name. Now, when you have multiple substituents, you list them alphabetically. Okay, so the prefixes such as di, tri, tetra, etc. that are used to indicate the number of identical substituents, they are not considered in alphabetizing. For example, if you have 2-methyl, so we write dimethyl. So we only consider letter M. Okay, for cycloalkanes, you just add the prefix cyclo. Okay, so that's why it's cycloalkanes. So if you have 3, it will become cyclopropane. Now let's have some examples to make it clear. Write the name of the following organic compounds. So this one is an alkane because it doesn't have a ring. First step is to identify the longest chain. Okay, so the longest chain would be this one. This is the longest chain. Why is it the longest chain? Because it would have 1, 2, 3, 4, 5, 6. If we consider this, we'll only have 1, 2, 3, 4, 5. Okay, that's why we go with the black one. Okay, so This is 1, 2, 3, 4, 5, 6. So this is a hexane. Next, we identify the substituents or the carbons that are not part of the longest chain. So we have this. So this 1, 2. So the name would be ethyl. Next, we number the carbon atoms starting from the end closest to the first substituent. So if we're going to look from right to left, so 1, 2, 3, 4, this substituent will have a number 4. But if you go from left to right, this will be 1, 2, 3, 4. So this substituent will now have number 3. 3 is lower than 4, so we adapt left to right. This would be number 3. Now let's assemble the name. So we start with 3-ethyl, and then this one, the base name, hexane. Okay, so the name is 3-ethyl hexane. Let's have another one. Again, as mentioned before, cycloalkanes have more priority than alkanes, so the base name would be the cycloalkane. So this cycloalkane has 1, 2, 3, 4, 5, 6. So the base name would be cyclohexane. Then identify the substituents. So you have this and this one. This one has 1 carbon atom, so the substituent would be methyl. This substituent has 2 carbon atoms, so that would be ethyl. And then we number the carbon atoms starting from the end closest to the first substituent. Since ethyl has more carbon atoms, it has more priority, so we count from here 1, 2, 3, 4, 5, 6. Again, we can't go clockwise because this would have a number 5. Now let's assemble the name. Again, the names should be in alphabetical order, so ethyl should come first, followed by methyl. So the name would be 1-ethyl dash 5 dash methyl. So the name is 1-ethyl 5-methyl cyclohexane.